In this tutorial, I will demonstrate how to perform brain tumor segmentation and volumetric analysis from MRI using 3D Slicer, a free and open source platform for image processing and analysis. We will start by segmenting and isolating the tumor, then calculate its volume, export it as a 3D model, and finally create a 3D rendering of the scan and tumor for clear visualization. Let's start by loading a free sample dataset that comes with 3D Slicer. You can find it in the Welcome module. So first select Download Sample Data, then click on MR Brain Tumor 1 to load the dataset. Once it's loaded, you will see the MRI scan displayed in the three standard orthogonal views: axial, coronal, and sagittal. And the tumor is clearly visible in the sagittal view right here. As a very first step, I always recommend turning on the crosshairs by clicking the crosshair button up here. This helps you better understand exactly what location each view is showing. Now, to quickly jump to any point in the scan, you can hold down the Shift key and hover your mouse over the scan. When you do this, all three orthogonal views will automatically update and show the same point where your mouse cursor is. Now, the tumor is clearly visible in all three views. The foundation and first step of any volumetric measurement is to segment the feature of interest. By segmentation, we are basically telling the software, this is the structure I care about, and this is what I want to measure. To start the segmentation in 3D Slicer, we first need to open the Segment Editor module. Next, in the module panel, make sure the correct volume is selected as the source volume. Now, we can click Add to create our first segment. I will double-click on the segment name to rename it. Let's name it Tumor, and I'll choose a red color for better visibility. Since this MRI scan has a pretty good contrast between the tumor and surrounding tissue, we can use the threshold tool. So I'll click threshold right here. The red highlighted areas you see are a preview of what will be selected. But we need to adjust the threshold range so that it captures the entire tumor properly. Keep in mind, the threshold range I'm choosing here might not work for other scans. So for your own cases, you will need to use your judgment and adjust the values based on your data. Now, if I adjust the upper threshold a bit, you can see the tumor is being selected very nicely. But I will also adjust the lower threshold to reduce the other areas being selected. Something like this looks good. And apply. Now you can see that the tumor is selected, but some other unwanted areas are selected as well. And if I show this in 3D by clicking the Show 3D button over here, you will notice that many different regions are included in the segmentation. In the next step, we are going to clean up the selection. For this, we will use the smoothing tool. So I'll click Smoothing, and I will change the smoothing method to Opening, which is extremely useful for removing narrow unwanted regions. The kernel size is very important here. If you choose a value that is too large, you may lose details of the tumor. And if you choose a value that is too small, the cleaning won't be effective. For this dataset, I will choose a kernel size of 5 millimeters, and then click Apply. Now we can see that the unwanted selected areas are reduced significantly, while the tumor selection stays intact. If I scroll through the axial slices using the mouse wheel, you can see the tumor is still selected very nicely. At this point, since the tumor is not connected to other regions and can be considered as a separate isolated island, we can use the Islands tool to isolate it and remove the remaining unwanted selections. So I'll go to Islands and choose Keep Selected Island. Now I will click on the tumor in one of the 2D views. Perfect. Now the tumor is clearly segmented and we can explore it in 3D view. Looks quite nice. Now, we can measure the volume of this segment. To do so, we will open the Segment Statistics module. You can find it quickly by clicking the magnifier icon for the module search and typing statistics. Once you switch to that module, make sure the correct segmentation is selected as the input. We will leave the output settings as they are and click Apply. A table will appear at the bottom of the screen, and here you can see the reported volume of the tumor segment. Now, to export this segmentation as a 3D model, we go to Module drop-down menu and select the Segmentation module. In the Module panel, make sure the tumor segmentation is selected by clicking on it and confirming that it becomes highlighted. Then scroll down to the Export-Import section. We will keep the operation set to export and export the segment twice. First, as a 3D label map, and second, as a model. Now we need to go to the Data module. You will see the newly created outputs. This one is the label map. If we right-click on it and choose Export to File, we can select the file format. For example, NRRD, RAW, VTK, or other 3D volume formats. And for the created model, if we right-click and export it to file, we can save it as a surface mesh such as PLY or STL. Now, if we want to visualize the tumor inside the patient in 3D, we can use volume rendering. First, double-click the 3D view to enlarge it. Then, from the module drop-down list, go to the Volume Rendering module. Make sure the source volume, which is MR Brain Tumor 1, is selected. Then, in the inputs, choose the option to create a new volume property and click the eye icon next to visibility. Now, the 3D rendered volume of the original dataset appears in the 3D view. You might notice some noise around the volume. To clean it up, we can use the Shift slider over here. You can drag it left and right or hover over it and use the mouse wheel until the rendering looks cleaner and more visible. That looks nice. To virtually slice through the 3D volume and reveal the tumor inside, we can use cropping. Click the eye icon over here to show the ROI and make sure the crop is enabled. Now, you will see a cube appear around the volume. You can grab the circular handles on each face of the cube and drag them inward to cut through the 3D volume. This allows you to slice through the brain and clearly visualize the tumor inside the patient in 3D. If I rotate the view, you can see the tumor is nicely visible. And I can also crop from a different direction. For example, by using this face of the cube. And that's it for this session. Thank you for watching. If you found this workflow useful, please like the video and subscribe for more image analysis tutorials using 3D Slicer.